In the last class, could you write this derivation? Was it completed, the writing part?
Yeah, ma'am.
Okay. Did I discuss the denser to rarer one also? That was left, I think.
Yes, ma'am.
Okay. See, in the denser to rarer one, no, the difference will be this is your denser medium. This is the rarer medium. Now see, this is the spherical refracting surface. So from the denser means the glass part, the light ray is going towards the air part. Now look, this is the object. The light ray comes from the object. This is the surface. So what we do? We drop a line from the surface of the mirror, surface of the glass to the center of curvature that forms a straight normal, means perpendicular to this surface is obtained. So what happens? The light ray is deviated from this. Instead of taking this outside one, you consider this. This is your angle of incidence. Okay. Now the light ray will bend. It will deviate because medium has changed. So this becomes a refracted ray. This is the refracted ray. Okay. This is the incident ray. Now what happens? This refracted ray with the normal will make the angle of refraction. Same derivation class. See, this is alpha, this is beta, this is gamma. Difference will come with the fact that we will be considering, see, angle of incidence and angle alpha in triangle MOC. You can clearly see that angle of incidence plus alpha is equal to gamma. So angle of incidence will be gamma minus alpha. This is one point. Second point, if you look in this triangle MCI, in triangle MCI, the angle of refraction is equal to gamma plus beta. Okay, so these are the difference. In the previous case, if you have gone through the derivation, angle I was equal to sum of 2 and refraction was equal to difference of 2. Here they'll be this. Okay, so you solve them. This is the answer. What you will get, n2 by minus u plus n1 by v, n1 minus n2 by. Try this, write it, check whether you're getting the same answer or not. But at least write down this part. This you can do at your place also. Right now, let's discuss a numerical after this. And then we'll move on to the lens part. Okay, first write down. Okay, I should share the date sheet too. So I'll also get an idea when your exams are there. At least mention the physics and the starting date of the exams. Okay, Zainab, your paper is starting on 16th and physics is on 23rd. Okay, all right. And one more, Marva. Marva, you had your exam. How was it?
Yes, ma'am. It was actually quite easy itself, but the problem was that if everything was like based on
Based on
ba-
peak?
based on like deep seated, uh, like the concepts. So it was based on concepts. Numericals weren't asked much. Like just two numericals were asked.
Okay. Can you share the paper with us?
Yes, ma'am. I did.
Okay. Ray optics, wave optics, atoms, AC, EMI, nuclear, semiconductors are coming. Okay, Aisha, this is the syllabus. So we are on wave, okay, ray, waves, atoms, nucleus means second book plus AC and EMI are coming. So AC and EMI are done. Ray optics. Tell me the date, Aisha. Okay, 17th November. All of you are having the exams in the month of November. Wave optics, 23rd November is the physics. No, starting is 16th. Okay, Zainab, if it is not done, no, in the batch, because now ray optics isn't like much lens, an optical instrument, and prism. Three major topics are there from this chapter. If it isn't done, then definitely I'll put your extra class. Just keep reminding me before your exam if it isn't done. Let November start. Next week we'll have the classes there. Okay. And Aisha's is also on 17th November. And yours is on 16th. Sunday is you. No, your physics is on 23rd. Exams are on starting from 16th. Okay. So these are the pre-boards or mock pre-boards? Like we have two pre-boards, no? So first pre-board one, or is it the complete pre-board? Because one occurs in December. What kind of exams are these in the month of November, which you all are having? Hmm?
Ma'am, we have pre-board 1, pre-board 2, and then mock.
Okay. Okay, your is term 2. Okay. See, one numerical based on this. This is from your NCRT. Think. This is a sunshine recorder globe of 30 centimeter diameter. Is made of glass of refractive index. Yeah, I get it. Pre-boards and will be the final pre-boards, like before your boards will be in December and January. No, yeah. So usually we target these only December ones, but midterm, let's see how much we are able to do because November is very early. At least I need the complete month. Okay, November we'll have to see. Whatever time will be taken in the waves chapter. That isn't very much lengthy. Semiconductors, atoms, nuclei, dual nature, very short chapters. But let's see how much we are able to do. A sunshine recorder globe of 30 centimeter in diameter is made of glass of refractive index 1.5. Glass ray enters parallel to it. We have to find out the position where the ray crosses the axis. See, basically what happens, this ray of light is coming. Now this is occurring as a spherical refracting surface, but at 2 points. See, when the light enters over here, the second part was not present. Please listen to it carefully, because we'll be deriving a lens maker formula afterwards, so it will be very much used over there. So the ray of light will be deviated initially at this A point. Then what will happen? Then you have this B point. If this part wasn't present, the ray of light would have gone straight, and here an image would have been formed, which is not there, but it would have been formed. These kinds of images, we call them as virtual, right? Because they are yet not formed. So this will be an intermediate image. Intermediate image will be formed here. Now, this intermediate image will act as a virtual object for the next surface. See, this light ray will come, no? This ray of light will come only and act as the incident ray of light. So what is this? What exactly is this ray? This is actually this. So that's why we say this is a virtual object. And I think I have discussed a lot virtual and real and all. So by now, we did a question also similar to this. So this is the intermediate image which will be acting as your object over here. Okay. Finally, one more refraction occurs and the final image is formed. Let's say this is U will be at infinity. Parallel ray of light is coming, though this isn't looking parallel. You draw it parallel in your notebooks. This is air, so this will also be air. This is glass. At first point, the refraction occurs from rarer to denser. And then at the second point, denser to rarer. This is the only thing that you have to apply. See, for the first case, the value of N1 will be 1, N2 will be 1.5, U will be infinity, image will be this V dash, because that is the temporary one, no? Intermediate image that has been formed. But for the first refracting surface, this is the image. So V dash will be used, class. Okay, V dash will be used straight away. Radius of curvature is fixed. See, the diameter of the entire glass is 30 centimeter. So radius of curvature will be 15 centimeter. N1, N2, U, V are all are there. What you are going to apply? You have to apply the formula for rarer to denser. Okay. N1 by minus U plus N2 by V is equal to N2 minus N1 by R. Okay, straight away we'll be using this formula. And this one. N1 by minus U plus N2 by V is equal to N2 minus N1 by R. Okay. So from here, see, U is already infinity. This will be 0. This V will be your V dash, which you have to find out. This you can calculation part, please do it on your own and tell me the answer. Now, in the second half, your N1, the first medium, is your glass. That is 1.5. And N2 will be air, which is coming out 1. Okay. Radius of curvature will still be the same, 50 centimeter. Now see, object distance will be what? Object distance will be V dash, because that is the virtual image, virtual object is your I dash. So V dash will be the distance that we'll be considering. Whatever you will calculate, you will put it here, V dash. Okay. And whatever is the final image that we have to find out, we will have to calculate. Formula you will use N2 by minus U plus N1 by V is equal to N1 minus N2 by R. This minus U will actually be minus of V dash, this value. And then you calculate what's the value from here. The point where it crosses, see, if you want to get the gapping between these two images, this will be V dash minus V, this length. Okay, write it. Tell me what are the values you all are getting. First, write down the question and the figure. Then afterwards, after this, immediately I'll start with the lens part. Okay. Calculations you can do later class. Let's come to the lens. See, as we discussed that when you have a spherical refracting surface, you cut it into portions, right? You silver polish one side. That gives you a mirror, right? And if you don't polish it, that becomes a simple spherical refracting surface. Now, if you take such two spherical surfaces and then join them, that gives you a lens. Like if I take this part of a lens, this part of a lens, now I join them. This gives a concave lens, convex lens. Like this is a biconvex lens, which we say double convex. Means, see, this part is the convex part, this part is the convex part. What all combinations can be made? See, if I have a plane part and I have a convex part, so this will be known as a plano-convex. Plano-convex. This will be biconvex or double convex. If I take concave side and a convex side, see, this is the concave part, while this is the convex part. So this is known as a concavo-convex thing. Similarly, if I, instead of joining them like this, if I join it in the opposite direction, like this, that gives a double concave lens. This part is the concave part, this part is the concave part. So biconcave lens or double concave. Similarly, you can see this is a plane part, while this is a concave part. Now, again, if I take the convex side, that becomes convexo-concave. Same thing, whichever is dominating, or concavo-convex. Same thing will be there. There won't be any difference, right? Whether you take convexo-concave or concavo-convex. Same thing. So the most common that we'll be using will be this one. In the exam also, like in the mirror, we had concave mirror important. Convex lens are often asked, but of course, concave can also be asked. Plano convex can also be asked. This we will be doing in one of the applications also. But see, what will be the difference? Difference will come that plane part will act like a plane mirror, plane surface. Radius of curvature will be infinite, while this will still be having a radius of curvature. I'll discuss this. You will be able to get this. Now, few terms, when you join them, the rest of the terms are there, but you have a center of the lens as well, right? So, center of the lens will be known as the optical center. So, the center of the lens, this is known as the optical center. Okay, both the lens. Now, what did we discuss? The principal axis, wherever it cuts the lens, that gives you the pole. So here two poles will be there, and since two poles are present, two focal lengths will be there, two radius of curvatures will be present. Like if I tell you this, two foci will be there, F1 and F2. This is the primary focus, this is the secondary focus. Wherever light rays will come, see, convex lens are converging lens. Usually, this I'll discuss after lens maker formula. That can it behave like a diverging or not? That we'll discuss later. But usually it is a converging lens by nature. So this is the primary focus. Okay, we say first primary foci, second primary foci. Similarly, this is for the concave. It is a diverging lens. Now after this, I'll be discussing the derivation of the lens maker formula. But I hope this basic part is clear. What is a lens is clear. Lens is a very common thing. This lens is present in the specs also. Thickened. How to identify convex lens? It will be thickened in the middle part, thin over the edges. While concave will be thin towards the central part and thick towards the edges. Like if you see usually the specs of old people, they have a thin part here over here. There's a thin part which is in fact visible also directly at the if you look at their specs. So they have a lot of applications. The lens also have a lot of applications, and the human eye has convex lens present. The image that is formed on our retina is inverted image. Later on, it occurs that the optic nerves from the retina takes it to the motor cortex, where the sensory association areas are present in your brain. So human eye lens are also convex lens. Exactly, convex lens are present. So in the surgeries, ophthalmologists were replace it with the convex lens. And other applications are also there for mirrors, lens, plane mirrors too. Spherical refracting surfaces don't have any application in your books, but it's a refracting surface. Definitely, it will be refracting. But these lens and mirrors, please go through the NCRT and write up the applications of it. At least two applications of each. These can be asked to you in the exam, especially in your Viva also, because practical exams will be there, external will be there. So she can ask this. Am I clear till here?
Yes.
Yes.
Marwa, Jobita, fine.
Yes.
Yes.
Okay, write it. Then we'll do lens maker formulas derivation. Can class?
Yes, ma'am.
Okay, let's come to the lens maker formula. See, lens maker formula, there are two formula. You have a lens formula. That is also there. Like we have a mirror formula, 1 by f is equal to 1 by v plus 1 by u. Similarly, you have a lens formula, 1 by v minus 1 by u is equal to 1 by f. But here the limitation is that because in mirror, what did we have? We just had the same surface and reflection was occurring. So focal length, image distance, object distance, they were enough for us. But in lens maker formula, it connects the focal length, object distance, image distance with the radius of curvature as well as the refractive indices. While in lens formula, you are just left with the object distance, image distance, and the focal length. But here, since you have medium, a different media will be there. Okay, two different media will be present, a different medium will be there. You will have different radii of curvatures, and also that's why we need a formula which connects all of these. That's why you have a lens maker formula and a separate lens formula. Okay, lens maker is different. I'm just clarifying it right now. Now see its derivation, it's fine. It's just that it involves the spherical refracting surfaces, and a question that we just did, a similar concept will be used here. The question, the numerical, the sunshine globe one, which we discussed, a similar concept will be used here in the lens. See, here what are we doing? We are doubly refracting it, which actually occurs in reality. But the curvatures and the distance and the length and the center separation of the optical center to the poles, these are very small. So when you draw them, like if I have this as my convex lens, so I'll draw it like this. This is how you have to draw the image formation of the ray diagrams. Okay, this is sufficient. You don't have to show the refraction because the refraction that occurs twice, it's very less. It's insignificant. So you can just draw it like this. But in reality, what happens is there are two surfaces present here. First surface here where the light goes from rarer to denser, and the second one where the light goes from the denser to the rarer. Okay, so understand the diagram first. This is a convex lens. You can take a concave lens also, you'll get the same answer, but take the convex lens only. Okay. In your NCRT also, convex is given in the derivations. You have the object here. A ray of light goes at the first surface. You join it with the center of curvature to obtain the normal, and the light ray bends. Now, like the previous question which we discussed, the second surface wasn't present, the ray of light would have gone straight and an image would have been formed, which is the temporary image, that is I1. Okay, that's why we did the question, similar question before. Object, the ray of light is going, this is your incident ray, this is the refracted ray. Okay, refraction has occurred at this first point. First point means this is N1, this is N2. From N1 to N2, rarer to denser, air to glass, the light ray is entering. If the second surface wasn't present, the ray of light would have gone straight and here an image would have been formed. Since it is interrupted with another surface, so this ray of light, which was the ray of light of the first image, which was the refracted ray of light of the first surface, now becomes the incident ray for the second surface, where the light ray is moving from N2 to N1, denser to rarer. So treat it as a spherical refracting surface at one point and another spherical refracting surface at another point. And the numerical which we did, same thing we'll be doing here. Same exact same steps we'll be doing. It's just that we'll be deriving a formula and we'll be concluding it in a manner which is favorable to us. So this is the ray of light. Now it will bend again and here you will get the final image. Now this first will have its center of curvature over here. This will be the radius of curvature. This surface will have its radius of curvature and the center of curvature. Fine. U is the object distance, and okay class, everything is measured with respect to the optical center in case of lens. Rest of the sign convention is the same. So I'm not doing the sign conventions again. Same sign conventions, what you've studied already in case of mirrors. It's just that everything you will take will not be with respect to the pole, because then you'll have two poles here. And again, your answers will be very fluctuating and so much precision isn't required. You take everything from the optical center. As I said, the next time when you draw the ray diagrams also, you'll have to draw it in this manner. You don't have to draw it and show the double refractions. Because see, when a ray of light comes, the double refraction that will occur, this gap is very less actually. V1 minus V is in reality very less, and the thickness of the lens is also not big, because you can't exceed it much. Otherwise, if the distance is very, very greater, then the purpose of the lens dissolves. It becomes a complete refracting surface. There's no point of taking lens. Lens are taken so that image is magnified, it is diminished, it is there according to our convenience, right? So this becomes the object distance from the optical center to this point O1. Radii of curvatures I've already mentioned. The final image which is formed, which is visible, that is V, the separation. And the intermediate one, I'm taking it as V1. Same, I'm repeating the same thing, that the question which we did before, same values I'm taking, and we will be applying it with the same method. Now at the first point, this is from rarer to denser. So we'll apply this equation. N1 by minus U plus N2 by V1 is equal to N2 minus N1 by R1. Then you take the second point. Now for this object is O1, image is I1. Okay. So we have to get value of V1 from here. Like we don't have to right now, but actually V1 is the final image. Now for the second surface, this V1 will act as the object and V will be our final image which we are trying to calculate. And we will be taking the formula for denser to rarer, N2 by minus V1 plus N1 by V. This is actually minus U, but here U is equal to V1. So we have taken minus V1. So I1 is our object and I is our final image. These two equations are sufficient. We'll be just doing slight calculations, manipulations, and we'll be using a little concept of lens formula, which I'll tell you in between. Right, see what you have to do. Make the figure, write rarer to denser, denser to rarer equations, add them. Eventually, you'll get the answer by using lens formula. I'll tell you how. Let's add them first. This is N1 by minus U, plus this is N2 by V1. This is plus N2 by minus V1, plus this is N1 by V. This side, this is N2 minus N1. Oh, I have written this as N2 minus, this is N1 minus N2. So N2 minus N1 by R plus N1 minus N2 by R. Now I'll do one thing over here. Look, N2 by V1, N2 by minus V1. Same thing with a negative sign. N2 by V1 minus N2 by V1. It will be cancelled. So from here we'll have N1 by minus U plus N1 by V. From this edge, I'll have N2 by minus N1 by R. I'll put a negative sign here so that I can reverse this, N2 minus N1 by R. Okay, because I want to take things common. Now see, if I take N1 common from here, I'll get 1 by V minus 1 by U. Correct? 1 by minus U is minus 1 by U plus 1 by V. So plus 1 by V minus 1 by U is equal to, take N2 minus N1 common, 1 by R. I didn't write R1, R2. R1, R2, R1, R2. Okay, so 1 by R1 minus 1 by R2. Now, see, this whole term is actually from the length formula. As I told you before, that length formula is 1 by F is equal to 1 by V minus 1 by U. So I'll write 1 by F instead of that term. N1 was there, N2 minus N1 by 1 by R1 minus 1 by R2. Bring this N downwards. 1 by F will be N2 minus N1 by N1, 1 by R1 minus 1 by R2. Separate the denominator terms. 1 by F will be N2 by N1 minus N1 by N1. 1 by R1 minus 1 by R2. Yes, N1 will be cancelled. It will give you 1. N2 by N1 can be written as N21 minus 1, 1 by R1 minus 1 by R2. This is your lens formula. Sorry, lens maker formula. And N21 is what? The refractive index, relative refractive index of second medium with respect to one, which we have already discussed when we started refraction. So two formula are here. Lens maker formula is 1 by F, N21 minus 1, 1 by R1 minus 1 by R2. Lens formula is 1 by F is equal to 1 by V minus 1 by U. Lens formula also has a derivation that we'll do later. First, we'll be practicing lens maker formula questions, its applications. First, let's complete this. It's a very, very, very important topic. More than lens formula, lens maker formula's derivation is asked. But before that, you all tell me, see, what did I do? First, we had the figure where we actually broke up the incident ray of light into two parts, where actually it was getting refracted. We took both the points. We considered them, which we usually do not consider. For the first end, we took the ray of light from the rarer to the denser medium. We had that equation. Then we took the ray of light from the denser to the rarer medium with the object distance to be that of the intermediate object, or you can say virtual object formed. So we took the formula for denser to the rarer medium. We had the two equations. These two equations, we added them. We took the common values. We cancelled these two. When we took the common values here, we could insert the length formula, which could give us the reciprocal of the focal, that is 1 by f. We shifted n1 so that we could get a relative value and a simplified formula. 1 by f is equal to n21 minus 1, 1 by r1 minus 1 by r2. Is it clear till here to everyone?
Yes,
Yes,
ma'am.
ma'am.
Yes.
Muniba, Zainab, understanding?
Yes, ma'am.
Okay, please write the derivation, and in your notebooks, please mark important also. Lens maker formula is very important. If you look at the previous year questions in the board exams, pre-boards, it has been asked a lot. Please write it.
Can you please scroll down? See.
All done?
Yes, ma'am.
Yes, ma'am.
Let's practice a numerical from this. See, this is a concave lens. You have R1, R2 radii of curvatures are there. 10 centimeter, 20 centimeter, 1.5 is the refractive index. This is definitely here. Now see class, in these you have to obey the sign convention. See, only in ray optics, one portion, that is your optical instruments, there you don't have to abide by the sign conventions. Whatever formula we'll be deriving, just put in the values as it is, 10, 20, 30, 40, whatever is there. But for any of the things that we are using in the ray optics, the formula will be required to put up in the sign conventions. So for everything that we are using, put up the sign conventions from your end itself. And the sign conventions for the mirror and the lens are the same, except the fact that here you have everything from the optical center because two poles are present. There you had everything with respect to the poles, just the poles were there. Okay, now look class. Here, the first medium, air, this is your glass. What do we have to calculate? N1 will be 1 because it's air. N2 will be glass, which is 1.5. It is mentioned 1.5 in this particular question. It can simply mention glass also, or it can not mention anything too, because it's a lens made up of glass. Like this also it can be used because surrounding medium changes. Glass will be the same. So remember 1.5 definitely. Now radius 1, radius of curvature 1. This is lying in front of the lens. In front of the concave lens, this is lying. So in front of it will definitely be negative. In front of the mirror, in front of the lens, negative. See, we always take the object distance negative. Then we will have the radius of curvature. This will be positive. And N1, N2. What else? We have to calculate the focal length. Okay. So object is, see here the object distance that isn't actually required. N1, N2 are sufficient, right? Object distance will actually be infinity. Now let's just put in the formula. 1 by f will be N2 by N1 minus 1 1 by R1 minus 1 by R2. So 1 by F will be 1.5 minus 1 minus 1 by 10 minus 1 by 20. 0.5 into minus 3 by 20. So focal length is equal to minus 40 by 3 centimeters. So formula based question. Is this question clear to everyone?
Yes, ma'am.
Okay. Write it. Okay, Zainab, take the screenshot. Then you can leave.
Ma'am,
Yes, Jovita, say.
ma'am, how do we got minus 40 by 3 centimeters?
You multiply this with 2. This will be 20 in the denominator. 20 minus 2 minus 1 minus 3. What is 0.5? 1 by 2. 2 into 20 is 40. So 1 by F is this. Reciprocal of it will be.
Okay.
Right? Just extra done once completed. Okay. Others?
Done, ma'am.
Done? Okay. I've given you 6 questions from this topic. Let's make a formula. Easy questions are there. Just go through the assignment once and please submit it. Many of you are not giving the assignments recently. Okay. All right, then I'll stop you. As you are completing, you can. Okay.